Alright, so I chose 90 miles per hour and 300 feet. Ignore this value right here, but I turned 90 miles per hour into feet per second, which is about 132 feet per second. And then I plugged in my values into my parametric equation here. And the 132 represents the initial velocity. This 3 is how much it started off above the ground. And we're solving for the angle right now. So we know that it lands on the ground at 300 feet, which is an x-intercept, which is why I plugged in 300 for x, 0 for y. And then I took this equation right here, and I set it equal to t, and this is what I got. And then I plugged in this equation into the t variables that you see in the second equation here. And then what I did is I simplified this equation. Right here, I multiplied these out, and you get this. 132, that crosses out. Sine over cosine turns into tangent. Over here, I turned the 1 over cosine into secant. And then I squared this all and multiplied by negative 16. And you get negative 82.64. And I substitute the secant squared with tangent squared plus 1. And I multiplied that out, and I got this equation. And I turned the tangent into x, so I could plug this into a graphing calculator and solve for the zeros. And then once I found the zeros, I substituted x back for tangent, and I found the inverse tangent of them, and I got these two angles. And then in order to figure out which one's the right one, I plugged it back into my original equation right here. I plugged it in for a, solved for t. This is 7.93 seconds. This angle turned out to be 2.37 seconds, and this angle is the more logical one since it's traveling at an initial velocity of 132 feet per second. About 132 times 2 seconds, that's about 300 feet, so that's the logical choice right here, 16.07 degrees.